Hello children, we'll start with the C part of this chapter. Okay, C part, it says sign convention and lens formula. Sign convention and lens formula. Okay, so last year in mirror also we had, that was mirror formula. Okay, so this year we're going to have something called lens formula. So these are basically numericals based on concave and convex lenses. Okay, now first we should know what is the lens formula. According to the lens formula, 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by v minus 1 by u, where u is the object distance, v is the image distance, and f is the focal length. F is the focal length. Okay, so object distance, image distance and focal length. So if you see this diagram, object distance means distance between object and optical center. This is u. Image distance means distance between image and optical center, that is v. Focal length means distance between f and o, that is f. Okay. Now, the important thing is sign convention. Sign convention means in some cases u is positive and in some cases u is negative, and we should be able to take it clearly. While solving the numerical, it's very important that we use the proper sign convention, otherwise you won't get the answer. Okay, so now if you see the sign convention, basically the rule says any distance taken to the against the incident ray. Now see, in this case incident ray is coming like this, right? And so your u distance is between object and optical center. Now O is the reference point. Okay, so when I measure u, I measure from O to the object position, which is opposite to the direction of incident ray. It is opposite to the direction of incident ray, so those are considered negative. Whereas V, it is in the direction of incident ray, so V will be positive. Now that's the rule, actual rule, but we'll try to I'll try to teach you some shortcut way to remember or some easy logic to remember. You can take like this: anything to the left of your lens, okay, will be negative, and all the things that are to the right will be positive. Is it clear? Anything to the left will be negative and to the right will be positive. Using that, if we take, so we are seeing about sign convention. So there will be three categories. So in convex lens itself, case 1 to 5 will fall under one category, case 6 will fall under one category, and concave will have only one type. So in convex itself, case 1 to 5, then case 6, concave has only one ray diagram, two ray diagram, you know that. So in convex case 1 to 5, u is to the left, so u is negative, v is to the right, so v is positive, f is also positive. Now you can have a question, ma'am, there is an f here also, but if you remember, we are not considering this focus, we are only considering this focus, the ray passing through this focus, so we are considering second focus in all our ray diagrams, so this is the focal length, so f will also be positive. Coming to case 6, now case 6 is little different. Why? The image is virtual image, it's formed behind the object itself, on the same side of the lens. So what happens? U is also to the left, V is also to the left. So U will be negative, V will also be negative, only F will be positive. Only F will be positive. I hope you are clear, children. Now coming to concave. Here the diagram is here. So if you see in concave, the focal length will be this one. In a concave lens, we will always consider this. This is the second focus for concave. For convex, this is the second focus. So we consider this. For concave, this is the second focus. That's why we drew a ray in such a way that when you extend it, pass through this F. We are not considering this F. So focal length is here. Object distance is this, U, and image is here, so image distance is V. So what's the conclusion? Everything is to the left. Okay? All three are to the left. So what will happen? U is also negative, V is also negative, and F is also negative. Is it clear, children? So this is the sign convention. You have to remember it before solving the numerical. Is it clear? So please note this down in your notebooks. Lens formula and then sign convention. So under these three categories, convex case 1 to 5, convex case 6, then concave, there is only one ray diagram. Is it clear? I hope you are clear with the sign convention. Now we'll start doing the numericals. Yeah, children, turn to page 127. Page 127. So we have the numericals. It starts from 126 basically, but I'm not doing in that order in which they have given in the book. Okay, I'm following a little different order so that it will be easy for you to follow. Okay, so I'm going to start solving the second numerical. Okay, I'm going to first start solving the second numerical. So you can write along with me as you listen to it first, then you write it. Okay, a concave lens forms the image of an object kept at a distance 20 centimeter in front of it. So it's a concave lens first of all. Okay, so image of an object kept at a distance 20 centimeter in front of it. So image of an object kept at a distance. So object distance is 20 centimeter. Then at a distance 10 centimeter, the convex lens forms the image of an object kept at a distance. So object is kept at a distance 20 centimeter. Image is formed at a distance 10 centimeter on the side of the object. What is the nature of image? Find the focal length and find the focal length of the lenses. So what is our sign convention for case 1 to 5, then case 6, then this is convex, then concave. So U negative, V positive, F positive. U negative, V also negative, F positive. For concave, all three negative. U negative, V negative, and F negative. Okay. So this numerical we are solving is concave lens. So U is also negative, V is also negative. So after writing the numbers, the first thing you have to do is put the sign. Put the sign. So both will have negative sign. Then you write according to the lens formula. Write the lens formula first. 1 by F is equal to 1 by V minus 1 by U. If you remember, in mirror formula you had plus here last year. Okay, that was mirror formula. In lens formula you will have minus. Now 1 by F is equal to 1 by V is minus 10. Don't forget to write the sign, otherwise your answer will go wrong. Minus 1 by minus 20. Okay, so minus 1 by 10, minus into minus, this will become plus. Okay, so 1 by 20. Now if you solve 20 in the denominator, so minus 2, okay, 10 into 2, so 1 into 2 minus 2 plus 1, that is minus 1 by 20. So f is equal to minus 20 centimeter. So focal length is minus 20 centimeter. Okay, focal length should be negative and you are getting the answer also in negative. Now don't put f minus here. Okay, only for the values that you are substituting you should use the sign. Okay, now the moment you think that concave may f negative and don't put minus f here. Okay, you just put f and calculate it, automatically the answer will come out to be negative. So we have done the B part first. Focal length of the lens happens to be minus 20 centimeter. Then for A part, what is the nature of the image? Nature of image: virtual, erect and diminished. Virtual, erect and diminished. That's the nature of image and this is the, okay. Is it clear, children? So this is the way, if u and v are given and f has to be found, we have to do that. Okay. Now come to numerical number 5. Okay. This is convex. Numerical number 5. An illuminated object lies at a distance 1 meter from the screen. Okay. So this is lens. This is your screen. Screen is on which you will get the image. And object, suppose if it's a candle or something, so this is the object. Now they are saying an object lies at a distance 1 meter from a screen. So this distance is 1 meter or 100 centimeter. 100 centimeter. A convex lens is used to form an image of the object on a screen placed at a distance 75 centimeter from the lens. So screen is placed at a distance 75 centimeter from the lens. So what can you conclude? This distance is 25 centimeter. Just to confuse you, they have given like this, children. Instead of giving u and v, they have given this distance, that is 100, and then they give you this distance and then you had to find u like this. So this is object distance. So image, screen is where image is formed, right? So this is u, this is v. So u is 25 centimeter and v is 75 centimeter. Okay. Now we have to see the sign convention. It falls in case 1 to 5. Convex case 1 to 5. So u is negative, v is positive. So u is negative, v is positive. Okay. Now let's write lens formula. 1 by f is equal to 1 by u minus 1 by v. Every time, 1 by v minus 1 by u. Every time, make sure you write this, you get marks for that. Then v is 75 plus 75. Okay. U is minus 25. So minus into minus, it will become plus 1 by 25. Now 75 will be the LCM. Okay. So into 3 into 3. So 1 plus 3, that is 4 by 75. 4 by 75. Or f is equal to 75 by 4. That is 18.75 centimeter. 18.75 centimeter. Is it clear? Automatically you got it to be positive because it is convex lens. Is it clear, children? So what all we were asked to find? Focal length of the lens, magnification. I'll come to magnification later. So now I hope you're clear with how to use the sign convention for u and v and find the focal length from the lens formula. Okay. Now we go to the next concept, that is magnification. That is magnification. Okay. So what is magnification? Magnification is how much the image is bigger than the object. Now in this case, this is case beyond to f to f. This is case 4. Okay, this is case 4. So you get image size bigger than the object. So magnification is basically the ratio of height of image or length of image upon length of object. Okay, suppose if this was 2 centimeter and this was 1 centimeter, what is the magnification? 2 by 1, that is 2. So the image is magnified by 2 times. Okay, so length of image upon length of object. Now, in this also there is a sign convention. Any height, okay, that is above the principal axis should be taken positive. And all the heights that you are measuring below the principal axis should be taken negative. So that way this will become negative and this will become positive in this case, for this case. Is it clear, children? What about the 6th case? 6th case, both object and image at the top, so both will be positive. And even for concave, both image, object and image will be at the top, so both will be positive again. Is it clear? So for virtual image, object and image height both will be positive. For real image, object will be positive, image will be negative. So accordingly, your magnification will become negative or positive. Okay, so convex case 1 to 5 and then case 6, then concave. Now in convex case 1 to 5, O is positive, I is negative. O positive, I is also positive. O is positive, I is also positive. So what about magnification? In this case it will be negative. In this case it will be positive because I upon O. So both are positive means this will also be positive and this will also be positive. This will also be positive. Okay. Now there is another formula for magnification, that is V by U. Image distance upon object distance. Image distance upon object distance. Okay. So there is a derivation for this, but that you don't have in your syllabus. You just have to know that magnification, either you can write it as length of image upon length of object. Usually we don't write length of, we just write I by O, okay, along with the sign convention, or V by U along with the sign convention. Is it clear, children? Now we go to numericals based on this. Numericals based on magnification now. Okay. Now, now that we've been doing the fifth numerical, second part. Okay, first part was focal length, second part was magnification. Second part was magnification. Now, so magnification will be I by O, but in this numerical we don't have I or O, but we have U and V. So you can use this formula V by U, and again along with the sign. Okay, so V is 75 and U is minus 25. So minus 3. Magnification is minus 3. Is it clear, children? So this is how you will solve for magnification. Okay. Now we go to numerical number 1. Now we go to numerical number 1. So now in this, the numerical starting itself is based on magnification. See the question. Listen, read very carefully. At what position a candle of length 3 centimeter, okay, can be placed in front of convex lens? Let's stop here. At what position a candle of length 3 centimeter. So what is 3 centimeter? Object height. So that is 3 centimeter. Be placed in front of a lens. So at what position? In front of the lens means U they are asking us to find. Use the question mark. So that listen, its image of length 6 centimeter. So what is 6 centimeter? I is 6 centimeter obtained on the screen placed at a distance 30 centimeter behind the lens. Screen placed at a distance 30 centimeter behind the lens, that is V 30 centimeter. Is it clear, children? So these are the numbers given. Now we have to use the sign convention. This comes under case 1 to 5. So because object is in front of the lens, image is behind the lens, so that is case 1 to 5. So in case 1 to 5, object is positive, image is negative. Yeah, then U is negative and V is positive. Remember? Okay, so this and magnification ka convention also. So in this itself you can take, children, I is, O is positive, I is negative, O is positive, I is also positive, O is positive, I is also positive. So M is negative here, M is positive here, M is positive here. Is it clear? Okay, let's do now. So we'll continue with the first numerical. Now before starting this, I want to tell you, children, that you have to note down all these classwork numericals also in your notebook. Okay, I know I'm not following the same order as given in the book. Okay, I'm doing 2, 5, 1, 4, 10. Please, you can use the same order, it's okay. Okay, that will help you to understand it better and then solve the homework later on. So I want the classwork to be written in the notebook, not only the homework. Okay, classwork also to be written. As you watch this, pause it and keep noting down the numericals. Okay, we'll continue with the first numerical. So 1 by F is 1 by V minus 1 by U. Now we cannot use V and U. We cannot use lens formula because you don't know F also, you don't know U also. So you cannot go use this. But because we know I and O, we can find magnification first. Magnification is I upon O, that is minus 6 by 3, that is minus 2. Now you know that magnification also has another formula, that is V by U. So I can write V by U is equal to minus 2 or U is equal to minus V by 2. Now that I know V, okay, I know V, so this will come later. So U will be minus V by 2, that is minus 30 by 2, that is minus 15 centimeter. So now knowing U and V, I can find F using the lens formula. So come to the lens formula now. 1 by V minus 1 by U. So V is 30 centimeter and U is minus 15 centimeter. So minus into minus plus. So it will become plus 1 by 15. 30 is the LCM. 1 plus 2. 3 by 30. Or F is equal to 30 by 3, that is 10 centimeter. So if I and O are given, then you have to use this formula first, get the relationship between U and V, and then you can put it. So this is the second type of numerical that we are going to see. Hope you are clear with this numerical. We'll go to the fourth numerical. I'm trying to solve all the difficult ones so that easy ones I thought of giving as homework. Okay. Now fourth one, where should an object be placed in front of a convex lens? Where should an object be placed? So object distance is asked. In front of a convex lens of focal length 0.12 meter to form a real image of size 3 times the size of the object. So image size is 3 times the size of the object on the screen. Okay. So convex lens to obtain a real image. So it's a real image in the sense case 1 to 5. It falls in the case 1 to 5 and it is meter. Okay. So magnification will be I by O, that is 3. Okay, this is O, not 30 children, this is O. Okay, so magnification will be 3. So if magnification is 3, then V by U will be 3. V by U will be 3. So you know that in the first 3 cases, in the first 5 cases of convex, M is minus 3. So V by U, you will get minus 3. So V is equal to minus 3U. Okay. So now what we do, 1 by F is equal to 1 by V minus 1 by U. Nothing else is given. Okay. So no, F is given. So 1 by 0.12 is equal to, in place of V, let's write minus 3U in place of V, so that in our expression you have only one variable. You will have only one variable. Is it clear? Because you don't know both U and V, you know F. So we are trying to write one in terms of the other so that you get one variable and you can find its value easily. So 0.12 is equal to, so it's minus 1 by 3U minus 1 by U. So 3U minus 1 minus 3. So minus 4 by 3U is equal to 1 by 0.12, or 3U is equal to minus 4 into 0.12, or U is equal to minus 4 into 0.12 by 3. That will be 3 4s are 12, right? 0.04. Okay, so 4 4s are 16. So 0.16 meter. The answer will be minus 0.16 meter. Either you write 0.16 meter in front of the lens or you write minus 0.16 meter. Both are one and the same. Is it clear, children? So now the same way, 10th question also, if you see, a concave lens forms an erect image of 1/3 the size of the object. Here image is 1/3 the size of an object. So what will happen to your magnification? I by O, that is 1 by 3. Okay, 1 by 3, O by O, that is 1 by 3. So your magnification will be 1 by 3, or V by U is 1 by 3, or U is equal to 3V. U is equal to 3V. So same way, now they have given it's placed at a distance 30 centimeter. Image distance is given, so you can find U and then put it in the formula and find V. Is it clear, children? So finish this also. The homework are 3, 6, 7, 8 and 9. 3, 6, 7, 8, 10 I have not completed. Please complete it. Then 3, 6, 7, 8, 9 are the homework. Thank you, children.